Electrostatic potential energy difference. That video I sent to you. Okay. Here I will explain it. Today itself, all of you have to watch those two videos and understand, because this is a very important concept. If you watch it, then only you understand the difference between potential energy difference, potential difference, etc. Okay. Here I will
Okay, ma'am.
explain. Here you can see a charge here. You can see a positive charge here, and we know positive charge electric field is outwards, and around that charge there will be electric field. Around the charge there will be electric field, and you consider 2 points A and B. Electric field direction outwards, but we are bringing the charge towards the charge opposite to the electric field. We are bringing the charge opposite to the electric field. So here, a charge Q, which is a test charge, which will not affect the field of the source charge. So this is a test charge Q. So a test charge plus Q, it is plus Q. This is also plus Q, big one, big Q. Source charge, this will repel this charge, but we are bringing it against the electric field. We bring this charge against the electric field. So the small distance AB, because electric field is considered to be constant at a very nearby points, electric field is almost constant. So the small amount of work done to take the charge Q from A to B. How will you find out work done? F dot dr. And how much work we have to do against the electrostatic field? That means our work done is considered as the external work done. So electric field will do a work on it to repel it. But we are doing a work against that to bring it to the point P through a small distance dr. So work done. F external is inwards, but Fe electric field force due to the electric field is outwards, but F external work done by us is inwards towards it. So that is both are opposite. External field, we are doing a work external to the electric field, that is towards the charge, and the work done by the electric field is away from the charge. So if the work done by us, that is equal to integral A to B, what total work done to bring the charge from A to B, integral A to B, F external dot dr, F dot dr, that we have studied, work done, F dot dr. And that is opposite to the electrostatic field. Our work done is opposite to the electrostatic field. So we have to put minus sign. Minus of integral A to B Fe, vector Fe dot vector dr. Then potential energy difference, delta U. Delta U means difference. Difference in potential energy. So delta U is the difference in potential energy. That is UB, U means energy, potential energy. UB minus UA. Where is potential energy more, children? A or B? Work done to bring. See, when we bring the charge closer and closer to the source charge, repulsive force will be more. So we have to do more and more work to bring it near and near to the source charge. So work done is more. We have to do more work at B than at A because of this repulsive force. So potential energy will be more near to the charge. That means at B, potential energy will be more than at A. So there will be energy difference. Potential energy difference. Potential energy at B is greater than potential energy at A. That means there is a potential energy difference. So potential energy difference is written as UV minus UA. UV is greater. UB minus UA, that is the work done to take the test charge from A to B. So potential energy difference, UB minus UA equal to work done to take the test charge from A to B. So that is the definition of potential energy. Then electrostatic potential energy of charge Q at B. So this is the difference in potential energy. We got the expression UB minus UA equal to WA. Work done itself is the difference in potential energy to bring the charge from A to B. Next, we are dealing with the potential energy of charge Q at B at one particular point. This is difference. But this is potential energy of a charge Q at B. At B. What is the potential energy of the charge Q at B? That is what we have to find out. For that, we have to bring the charge from infinity to that point, not from A to B. A to B will give potential energy difference between A and B. Suppose we want to find potential energy at B, we have to bring the charge from infinity to that point. So, in this expression, in the place of A, you have to give infinity. So, potential energy at B, how will you write the expression? UB minus U infinity. From infinity you have to bring. So, W infinity B. In the place of A, we have to write infinity. Then infinity at infinity, potential energy is considered to be zero. Infinite distance from a charge, potential energy is no need to do work. Potential energy is zero at infinity. Infinite distance from the charge, potential energy is zero. So U infinity is zero. So we get UB. Potential energy at B equal to W infinity B. The work done to bring a charge from infinity to that point B, that will be stored as electrostatic potential energy. It is, see, all these are similar to gravitational potential energy and gravitational potential. All those things we have studied last year. Similar manner, potential energy in that case we have seen. It is the amount of work done to bring a body of mass m from one point to the other. That is gravitational potential energy difference. But here it is charge. That is the difference. We are bringing the charge, test charge from one point to the other. So that is the difference. We can compare. Both these are, both the gravitational field and electrostatic field, both are conservative forces. Then as we can compare both of this. Potential energy of charge Q is the work done to bring a charge Q from infinity to that point. It is a scalar quantity. Potential energy is a scalar quantity. Unit is joule. Next is electrostatic potential difference. What is the difference? This is potential energy difference. That is the work done. But here it is electrostatic potential difference. Not energy is not that. Potential difference. Okay. And for that we have to find the work done to bring a charge, unit positive charge. This is the work done to bring a charge Q. Then what is the work done to bring a unit positive charge? WAB by Q you have to do. UB minus UA by Q. So this is the work done to bring a charge Q from A to B. What is the work done to bring a unit positive charge? So we have to divide it by this by Q, test charge, divided by the test charge. So UB minus UA by Q will give the electrostatic potential difference. So WAB by Q, that is equal to VB minus VA. Now potential difference is denoted with the letter V, potential. Energy is U, potential is V. Electrostatic potential difference, VB minus VA, that is delta V. Potential energy difference, delta U. Understand? So what did you understand from this? Potential energy difference is the work done to bring. Akshaya, tell, work done to bring what? Akshaya?
Yes, ma'am.
Potential energy difference is the work done to bring what? Work done to bring a charge or a unit positive charge. What is it?
Charge.
Work done to bring a charge. But potential difference, work done to bring a, tell, charge or unit positive charge. അറിയില്ല. മെഹർനിസ?
Unit positive charge.
Unit positive charge. So RWAB by Q it will be. That is the difference. Then potential at B. How will you define potential at B, children? Potential difference we got. Then potential at B, how will you define? By W infinity. That means from infinity you have to bring. The amount of work done to, yes?
The potential difference among the work done by unit positive charge to bring it from infinity.
Potential energy difference അല്ല, potential energy at B എന്ന് പറഞ്ഞാല് work done to bring a unit positive charge from infinity to that point.
Potential difference അറിയില്ലേ?
Potential difference എന്ന് പറഞ്ഞാല് യൂണിറ്റ് പോസിറ്റീവ്. അവിടെയാണ് യൂണിറ്റ് പോസിറ്റീവ് എന്ന് പറയേണ്ടത്. യൂണിറ്റ് പോസിറ്റീവ് മറ്റേ ടെസ്റ്റ് ചാർജ് ആണ്. ഇവിടെ യൂണിറ്റ് പോസിറ്റീവ് ചാർജ്. നമ്മൾ ഗ്രാവിറ്റേഷനിൽ പഠിച്ചില്ലേ, വർക്ക് ഡൺ ടു ബ്രിങ് എ ബോഡി ഫ്രം ഇൻഫിനിറ്റി ടു ദാറ്റ് പോയിന്റ്. അതാണ് പൊട്ടൻഷ്യൽ എനർജി എന്ന് പറയുന്നത്. ഇനി വർക്ക് ഡൺ ടു ബ്രിങ് എ യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് എന്ന് പറയുമ്പോൾ അത് പൊട്ടൻഷ്യലായി, എനർജി അല്ല, പൊട്ടൻഷ്യലായി. യൂണിറ്റ് പോസിറ്റീവ് ചാർജിന് കൊണ്ടുവരാനുള്ള വർക്കാണ്, അതാണ് പൊട്ടൻഷ്യൽ. മനസ്സിലായോ? It is the minimum work done in carrying a unit positive charge. എനർജി എന്ന് പറയുമ്പോൾ ബോഡി, അവിടെ നമ്മൾ ഗ്രാവിറ്റേഷനിൽ ബോഡി പറഞ്ഞു, അതുമാതിരി ഇവിടെ ചാർജ് എന്ന് പറയണം. പിന്നെ പൊട്ടൻഷ്യൽ എന്ന് പറയുമ്പോൾ വർക്ക് ഡൺ ടു ബ്രിങ് എ യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് എന്ന് പറയണം. വെറുതെ ചാർജ് പറഞ്ഞാൽ പോരാ, യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് എന്ന് പറയണം. വിത്തൗട്ട് ആക്സിലറേഷൻ ഫ്രം ഇൻഫിനിറ്റി ടു ദാറ്റ് പോയിന്റ്. സോ വി ബി മൈനസ് വി എ ഈക്വൽ ടു ഡബ്ല്യു AB by Q. Work done to bring the charge from A to B divided by Q. അപ്പോൾ യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് ആയി. Work done to bring a unit positive charge from A to B. That is the potential difference. So at infinity, in order to define electrostatic potential at B, we have to bring the unit positive charge from where to where? To define potential at B, the potential difference. Not to define potential, where to where we have to bring the charge, children?
From infinity to B.
From infinity to that point. That's the difference.
From infinity to B.
Yes, that's correct. From infinity to that point. So VB minus V infinity. Not from A to B. Infinity. So in the place of A, you have to write infinity. VB minus VA equal to W infinity B by Q. Understand? Infinity. In the place of A, we have to write infinity. So VB, at infinity, potential is 0. At a very large distance from the charge, the potential is 0. So because potential is inversely proportional to distance, potential becomes 0. We know that potential energy or potential in the case of gravitational field also we have studied. At infinity, potential is considered to be 0. Just like that. Both are conservative field, both the fields. So V infinity is 0, VB minus 0 equal to W infinity B by Q. So VB equal to W infinity B by Q. Work done to take a unit positive charge from infinity to that point, that will be stored as that potential of that charge. You can understand. Potential energy means W infinity B. W infinity B by Q will give potential at B. Understand? So you must know the difference between them. Then electrostatic force is a conservative force. Still, if you have doubt, you please watch the videos. We are not utilizing that. I am sending the video with a lot of effort. We are taking these videos and all, uploading it, but you are not utilizing it. You have no value in it. So electrostatic force is a conservative force. So here gravitational force is a conservative force. What is a conservative force, children? Do you remember? Last year we studied what is a conservative force. Work done to take a
Before and after energy, body is constant.
what is constant?
After the work done.
Work done. Work done to take a charge from one point to the other. Do not depend upon the nature of the path. That is what we have studied. It depends only on the position. You can take the charge from B to A through any path. But work done depends only on their positions. Where are they in that field? In that field, where are they? That depends only on the position, not on the nature of the path followed. So here, the work done to take the charge from A to B through this path. Suppose that we are taking positive, then work done to take the charge from B to A. For example, suppose electric field is in this direction. Electric field, this direction. And in the same direction, we don't need to do work because electric field will do that work to taking the charge from A to B. That repulsive force will be there if both are positive charges. And but to bring it against the electrostatic force, we have to do work. So one work is done by electric field, other work is done by the external field. So that work done by electric field, if we take positive, the other work done we have to take negative. So sum will be 0. Work done per unit positive charge VB minus VA. That from A to B, then B to A. Work done to bring the charge from unit positive charge from B to A. That will be VA minus VB, minus of this. So total work done will be 0 when we add both these. VB minus VA minus VA. Pavitra is coming only now. So sum will be 0. So electrostatic force is a conservative force, children. Work done do not depend upon the nature of the path. Depends only on their positions in the field. Next, electrostatic potential due to a point. This is very important derivation. All the other things are, derivations are not there, but the concept you should know. But here it is the derivation which is very important. Just like that, what is the electric field due to a point charge we studied now? All the derivations, potential due to a point charge, then potential due to a dipole, potential due to a number of charges, potential at any point, all such derivations we have to do as we have done in electric field. That means potential due electric field due to a point charge we have done, electric field due to a dipole we have done, electric field due to a number of charges, superposition principle. So that much derivation we have to do it here also. Only thing you should understand the difference. So here a charge is kept here. What is aim? Our aim is to derive the expression for electrostatic potential due to a point charge. So first you keep a point charge here and take a point P. There we want to find the potential. The electric field direction we marked vector E. Arrow mark is outward. This is positive charge. So where is the charge placed? At O. What is the direction of electric field? Outwards. Positive charge. Outwards. And here you marked 2 points A and B, nearby points. Why we take 2 nearby points? At nearby points, the electric field is almost uniform. What is the distance between A and B? Very small distance, dx. What you are bringing? Potential. To find the potential, do you want to bring a charge or unit positive charge? What is your answer, children? Adilakshmi, tell. Do we want to
Positive
bring?
charge.
Do we want to bring a charge or unit positive charge in order to find the potential? Adilakshmi.
Unit positive charge.
Very good. To bring a unit positive charge. So, work done to bring a unit positive charge from A to B. First, we calculate that. Then, we integrate the expression from infinity to that point P. P is at a distance R from the charge. Okay. So, first step is work done to bring a unit positive charge from A to B. What is the work done? What is the electric field at A? A is at a distance x, children. Electric field formula. Electric field to a point charge. Adul Krishna, what is the formula? Electric field to a point charge. Electric field at A due to the point charge Q. Adul Krishna. Alok. ആരൊക്കെ മിണ്ടാത്ത പാർട്ടീസാണ് മിണ്ടൂല. Aisha Hussain, what is the electric field at A due to this charge? Aisha. ഉറങ്ങായിരിക്കും മിണ്ടണപോലുമില്ല. Deebanksha, tell, what is the electric field at A due to this charge? ഒക്കെ അറ്റൻഡൻസ് കിട്ടാൻ വേണ്ടി അത് ഓൺ ചെയ്ത് വെച്ച് കിടന്ന് ഉറങ്ങാൻ തോന്നുന്നു. ഒറ്റ ആളെ കിട്ടില്ല. Deebanksha, what is the electric field at A due to this charge? Adul Krishna ആണ്. Adul Krishna, tell.
1 by 4 epsilon
1 by 4 pi
epsilon
epsilon
0
0
q by r square.
Q ആണ് നമ്മൾ Q by r square അല്ലേ? അത് സി യൂണിറ്റ് പോസിറ്റീവ് ചാർജിനാണ് നമ്മൾ കൊണ്ടുവരുന്നത് കേട്ടോ.
+1.
അപ്പൊ യൂണിറ്റ് എന്ന് പറയുമ്പോൾ 1 വരും. ഓക്കെ,
Yes, teacher.
ഓക്കെ. ഫോർമുല Q by r square ആണ്. Along OA produced ആണ്. Direction of electric field OA produced. Small work done in moving a unit positive charge from A to B equal to E dot dx. Small work done. How it becomes E dot dx, children? Work done is how it becomes E dot dx, children? Anyone? Can you explain? Work done equal to E dot dx. Anyone? Devika, Sunil, can you explain how you got this step? Small work done. We know work done F dot dr. Then how it becomes E dot dx? Work done is F dot dx. F dot dx. Then how it becomes like this? Devika, can you explain?
Yes, ma'am.
Can you explain? Actually, work done is F dot dr or F dot dx. Here dx is the distance. F dot dx. Then how this becomes like this?
Ma'am, the electric field.
Huh?
Electric field.
F dot dx is the formula. Then how it changed to E dot dx? That is the question. Do you know? Lakshmi Priya, can you tell?
Don't know, ma'am.
Krishna Sri, can you tell? ഒരു സ്റ്റെപ്പ് മുമ്പ് എഴുതേണ്ട സ്റ്റെപ്പ് കൂടെ എഴുതിയിട്ടില്ല എന്നുള്ളൂ. അഡ്വാൻസ്ഡ് ആയിട്ട് എഴുതിയെന്ന് മാത്രം മനസ്സിലാവുമെന്ന് വിചാരിച്ചിട്ട്. But how this become instead of F dot dx, how it changed to E dot dx? Anyone?
F
F
is equal to E.
E ആണോ?
1 by 4 pi epsilon 0 1 by r square.
F ന്റെ ഫോർമുല എന്താണ്?
F is equal to E, ma'am.
E ആവണത് എപ്പോഴാ? F equal to E ആവണത് എപ്പോഴാ?
When Q equal to 1.
Q equal to 1. F equal to QE ആണ് ഫോർമുല. Q ഇവിടെ 1 അല്ല. We are bringing the unit positive charge. So Q is equal to 1. So work done to bring a unit positive charge. Actually, F equal to Q into E. So Q is equal to 1 here. We are bringing the unit positive charge. That's why we wrote here E dot dr. So in the notebook, you can add one more step here. dw equal to F dot dx. F equal to Q0 E dot dx. Q0 equal to 1. Unit positive charge. That's why we got E dot dx. So E dx cos 180. E dot dx is E dx cos 180. How it becomes 180, children? How it becomes 180? Work done. We are doing the work from A to B. Electric field is outwards. Electric field is outwards. And we are doing the work towards the charge. So, what is the angle between them? E and dx. What is the angle between them? Gramya, what is the angle between them? E is outwards. When we are taking the charge from A to B, what is the angle? Gramya. No answer. Manu Shankar, what is the angle between them? Electric field direction outwards. We are taking the unit positive charge from A to B. That means towards. What is the angle between them? E and dx. Manu Shankar? No answer. Muhammad Adil? M.A. Muhammad Adil? മറ്റാള് ശ്രദ്ധിക്കുന്നില്ല വെറുതെ വന്നിരിക്കുകയാണ് മേഘ നിങ്ങൾ ഇങ്ങനെ പോയാൽ ശരിയാവില്ല കേട്ടോ അവരാണ് ശ്രദ്ധിക്കുക മിഥുൻ ടെൽ ആരാണ് പറയുന്നത് ആരായാലും പറയാം മേഘ മേഘ പറയൂ electric field direction outwards. We are moving the unit positive charge inwards. What's the angle between them? dx and e.
180
180 ആണ് കേട്ടോ അപ്പൊ cos 180 e dx cos 180. So that's why we got cos 180 is minus 1. So we got minus e dx. So work done is minus e dx. Therefore, total work done in moving unit positive charge from infinity to the point P. Total work done infinity integral integrate the expression within the limit infinity to r integral infinity to r minus e dx. E is substituted 1 by 4 pi epsilon 0 q by x square into dx. Here children, here actually the formula is q. Q itself you have to write. I will do the correction and send to you children. Actually this is q, electric field. Why I don't 1 I don't know. 1 into q, correct. 1 into q1 q2 by r square. No? So this is actually q itself children. That's why we substituted it here. You have to do that correction in your notebook. I will send that page. Okay. Or is your notebook with you children? Is the notebook with you? Then you do the correction here. This is actually q by r electric field at A. 1 by 4 pi epsilon 0 q by r square. Not 1. Please cut this one. Q by r square itself. Then here.
നോട്ട്സ് മുമ്പ് അയച്ചിട്ടില്ലേ
ഇത് അയച്ചു തന്നിട്ടില്ല അല്ലേ അപ്പൊ പിന്നെ ഇതൊന്നും അയച്ചു കറക്റ്റ് ചെയ്തിട്ട് അയച്ചു ഓക്കെ minus 1 by 4 pi epsilon 0 q by x square dx. This integration we have done last year. 1 by x square x raised to minus 2. Do you remember those steps children? Gravitational field, gravitational potential, etc. Minus q by 4 pi epsilon 0 x raised to minus 2 dx. How will you integrate this? Integral x raised to n dx, x raised to n plus 1 by n plus 1. So minus 2 plus 1 by minus 2 plus 1 infinity to r. Then minus 2 plus 1 is minus 1. So that into this minus become plus. Plus q by 4 pi epsilon 0. When what is the exponent here? Minus 2 plus 1. That is minus 1. X raised to minus 1. Infinity to r. Then next is we are giving the limit. This is x raised to minus 1. So we write it as 1 by x. Then only we are giving the limit. Upper limit 1 by r minus lower limit 1 by infinity. 1 by infinity is 1 by infinity. What is 1 by infinity? 0. So we take this part is 0. But here 1 by r is there. 1 by 4 pi epsilon 0. Q by 4 pi epsilon 0 into 1 by r. So we got the expression. This is the electrostatic potential at P due to the charge Q. Potential equal to work done to bring a unit positive charge from infinity to that point is equal to 1 by 4 pi epsilon 0 q by r. So I'll ask a question. Potential equation we got 1 by 4 pi epsilon 0 q by r. What is the electric field? This is a potential due to a charge q. What is the electric field due to a charge q? Children? Mohammed Adil, tell. What is the electric field due to a charge q? What is the equation? Potential equation is q by r. 1 by 4 pi epsilon 0 q by r. Electric field equation, please tell.
1 by 4 pi epsilon 0 into
Ah.
q by r square.
Very good, very good. So if it is electric field, q by r square is there. If it is potential, only q by r is there. So it's the difference. Very important to note such changes in the equations. So it do not obey inverse square law, inversely proportional to r only. Okay. So that derivation, write and study, children. Then variation of electrostatic potential with distance V is proportional to 1 by R. That's what I told. Inversely proportional to R only, not R square. But electric field is inversely proportional to R square. So when you plot a graph, distance and V or E, if you take along y-axis and distance along x-axis, we get a graph. Electric field, see, the curvature is more because it is inversely proportional to r square. Here the curvature is less, 1 by r. V and E, the graph with the distance. So more curved, which one will be electric field? That V. V is inversely proportional to R. E is inversely proportional to R square. That's the difference. Graph also important. Then electric potential due to a group of point charges. Here you can see a number of charges. Q1, Q2, Q1, Q2, Q3, Qn, etc. Which are at distances R1, R2, R3, etc. Rn. Here we have to find the potential at P due to all these charges. One charge we know. If only one charge is there, potential is 1 by 4 pi epsilon 0 Q1 by R1. Here a number of charges are there. So how will you find the potential, children? First, find potential due to the first charge, V1. Let us take it as V1. V1 is equal to 1 by 4 pi epsilon 0 Q1 by R1. Then V2 is equal to 1 by 4 pi epsilon 0 Q2 by R2. Just like that we have to write. Then last what we have to do, find the total potential. How will you do, children? Potentially, is it a scalar or vector? Potential, children. Neeraj? What? Neeraj, tell. Scalar or vector potential? Actually, it is the work done. So it is Neeraj, no answer. Nanaprakasham? Scalar or vector? Work done?
Yes, ma'am.
Eh?
Vector, ma'am.
Work done.
Vector, ma'am.
Work done vector ആണോ? നിവേദിത work done vector ആണോ?
Work done, ma'am. Work done scalar.
അതല്ല ഇവിടെ വർക്ക് ഡൺ അല്ലേ നമ്മൾ കണ്ടുപിടിക്കുന്നത്. വർക്ക് ഡൺ ടു ബ്രിങ് എ ചാർജ്, യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് ഫ്രം ഇൻഫിനിറ്റി ടു ദാറ്റ് പോയിന്റ്. We are finding the work done. It is the dot product of F dot dr, dot product, scalar product, scalar quantity. Potential is a? Potential is a? Tell me, children.
Scalar quantity.
Scalar quantity. Electric field is a? Electric field is a? Complete it. Scalar or vector? Vector quantity. Then flux is a flux.
Scalar.
Flux is a scalar quantity. E dot ds. Dot product. Okay, force is a electrostatic force. Force is a
Vector.
force.
Uh,
Vector.
vector quantity.
Force is a vector
Yeah.
quantity. But flux is a scalar quantity. Potential is a scalar quantity. Torque is a torque.
Vector.
Vector cross product. P cross E. P cross E. P sin theta. Cross product. So total potential we find by adding all the potential. Total potential at P equal to V equal to V1 plus V2 plus V3 plus etc. Vn. We are adding all the potential. 1 by 4 pi epsilon 0 Q1 by R1 plus 1 by 4 pi epsilon 0 Q2 by R2 plus etc. plus 1 by 4 pi epsilon 0 Qn by Rn. Then with the sigma we are writing that 1 by 4 pi epsilon 0 is constant. It is taken outside. Then sigma I equal to 1 to n, which is varying here, q1, q2, q3, that is varying. So there we put I, qi by r1, r2, r3, etc. also is varying. So we put there ri. So 1 by 4 pi epsilon 0 sigma I equal to 1 to n qi by ri. That is the expression for the potential due to large number of charges, n charges. So final expression we got here, V is equal to 1 by 4 pi epsilon 0 sigma I equal to 1 to n qi by ri. So children, very important for this, for doing problems and all. Potential due to an electric dipole. Next is potential due to an electric dipole. So you have to consider a dipole minus q plus q charge equal in opposite charges separated by a short distance. What is dipole moment? What is dipole moment? Priya, what is dipole moment? Priya. No answer. Ridubarna, what is dipole moment? Ridubarna. Also
The measure of
dipole moment is the measure of. How will you find dipole moment? Equation പറ dipole moment in equation പറഞ്ഞ ഋതു പറഞ്ഞ മറ്റന്നാൾ പരീക്ഷ എഴുതാൻ പോണ ആൾക്കാരനെ എന്താണ് പിടിച്ചു വെച്ചിരിക്കുന്നത് പ്രണവ് what is dipole moment പ്രണവ് ആൻസർ ഇല്ല പവിത്ര what is dipole moment
Yes, teacher. Dipole moment is used to measure the strength of an electric dipole.
what is the formula P equal to
QA.
Q into length 2a length of the dipole Q into 2a
Yes,
is
teacher.
it a scalar or vector
Scalar quantity.
dipole moment dipole എന്താണ് scalar ആണോ dipole moment
A dipole moment vector quantity. Teacher.
Vector quantity ആണ് ട്ടോ dipole moment is a vector direction is from dipole
Negative to positive.
negative charge to positive charge dipole moment okay so here it is a dipole two equivalent opposite charges separated by a short distance here I have taken the distance as L and from the center to the point M it is X so we have to calculate the potential at M along the XL line. So it is at a distance x from the center O of the dipole. Okay. Then we know the net potential. How will you find net potential at M? Potential due to first you have to find potential due to minus Q charge. Then find potential due to plus Q charge. Then you take the sum of that. Yes, we have superposition principle. Just like that, we have to add all the potentials. So first one, what is the potential due to minus Q charge? 1 by 4 pi epsilon 0. That instead of that, we have written K here, 1 by 4 pi epsilon 0. It is written as K. So K into minus Q by scalar quantity. So my sign we have to consider minus Q by distance from center to M x. So from minus Q to M, the distance is how much, children? What is the distance now?